Greetings everyone! Today I will review one of the cheapest Chinese LED fixtures from AliExpress out there. It is sold by Shehds for less than 20 euros. I bought one during a sale and paid 12.8 euros in total. They promise 10 watt of light output with RGBW color mixing, but not as a wash but as a focused sharp pin spot. Let's see how the fixture fares. This is a technical review from the point of view of an engineer, so be prepared for some graphs and tables. Let's get right in. The fixture is very small and completely made of plastic. It claims to have a 10 watt RGBW LED, but there are other fixtures out there that claim 30 watts of power for the same fixture, which seems more unrealistic. The website states that it has 220x10 lux, whatever that means. It utilizes a two-lens design and should have a sharp pin spot with a beam angle of 9 degrees. The fixture should be able to strobe between 0 and 10 Hz, and as it is often the case, they claim a 16-bit mechanic dimmer, which is completely made up. What even is that? Last but not least, the case is made of plastic, it is actively cooled, and the plug is fixed. The internals are as follows. First, there's a power supply board. This outputs 11.4 volts and puts them into the dimmer board. The dimmer then takes this voltage and sends the power to the LED. While being at this, the dimmer also sends the voltage straight to the 40mm case fan. The LED is mounted on a mini aluminum PCB with an attached heatsink. Here you can see the two lenses separately. One is fixed directly on top of the LED and the other lens is then screwed in at the front of the fixture. The case is very bad. It is bad looking, glossy injection molded plastic. It is wobbly, but arguably it could be worse. The powder coated steel U-bracket is only 1mm thick and it is too wide for the fixture, which means that it bends around the center hole if attached to the fixture. Not very confidence inspiring. The foil on the back side has an error. The label for up and down is switched around, and while this is not a big problem, it speaks much about the attention this fixture got during manufacturing. All in all, the build quality is really bad, and I would only place it one step above the 7x12 watt RGBW Shehds that I did my first review on. But obviously, you must keep in mind that this costs way below 20 euros. The unit uses a 40mm fan to cool the LED. The fan is not temperature controlled and runs straight off the 12 volt of the power supply. This leaves us with an audible but not too bad noise. I have seen much worse, but it is definitely far from perfect. A nice touch is the air filter that is above the fan. I doubt that it is really necessary and I would have used the money for something different, but it is nice to see. There is a small heatsink directly beneath the LED and the fan directly blows on this heatsink. It is, however, very small, and these big fins on the side are just decorative plastic. All in all, the cooling is definitely sufficient for a 10 watt LED. The Shehds Pinspot has a legit CE certification. They also put a shiny CE sticker on, just for good measure. So all good in that regard. Interestingly enough, this is the first Chinese fixture with an EU energy label. Of course, I had to check the QR code on the label, and it is for a unit that has a power of 126 watt. I don't know about you, but I get the feeling this label is not for the fixture in the package. But just a feeling. Before going into the details of the measurements, I want to prepend a small subjective evaluation. In a vacuum, the LED has an okay-ish brightness, but in comparison to another pin spot that we will take a look at in a later video, it is very dim. In the upper picture, both fixtures only project white. Right is our 10 watt fixture and left is the other one. The white is, as it is often the case, very bluish and not pleasant to look at. Surprisingly, the dimming curve is very good, particularly at the lower end of the brightness. It is not perfectly smooth, which gets increasingly clear at higher brightnesses, but in comparison to all the other fixtures I reviewed up to today, I prefer it being smooth at lower brightnesses and instead of the other way around. As advertised, the fixture puts out a spot with uniform brightness and a sharp edge. However, there is significant color fringing around the perimeter of the spot, as you can see in the lower two pictures. The left is an official advertising picture from Shehds, and the right is my own, with a white balance that is quite off, but with all colors full on. If you look closely, you can see a red area at the top, a green area at the top right, and a blue area at the bottom left. For the official one, I think it is obvious what I mean with color fringing. Then I proceeded to measure the brightness and the beam angle of the unit. I did that with the brightness sensor of a Samsung Galaxy S20 FE, so not the most accurate thing, but I think it should be fine for relative comparisons. This leads us to a maximum brightness of around 500 lux. Since it is a two-lens design with an almost uniform brightness in the center, I was not able to do a Gaussian fit, but it is clear that the brightness sharply decreases between 8 and 10 degrees. So their advertised 9 degrees seems correct. They advertised the power of the LED being 10 watt. But keep in mind they are the honest ones. Other manufacturers claim 30 watts. In contrast to all other fixtures I reviewed up to now, this fixture uses a constant current driving method. So I tested the LED with these measured current values. This went in the following order. First, I measured the current during on with the dimmer board. Then I disconnected the dimmer board and attached my lab bench power supply and set the current to what was measured before. Last, I noted down the voltage that my power supply applied to reach that current. In the end, I measured the total LED power to be 12.93 watt, which I already expected since the LED looks, feels and behaves exactly like our box standard 12 watt LED we saw in almost every other fixture up to today. But I suspect it is being slightly overdriven with DC at these currents, but that's just a feeling. The dimmer board is, as stated, the first one featuring a CC driver for the LED. For the power measurement, this however made no difference. I have explained my methodology in more detail in my review of the 7x18 watt RGBW Amber UV Shehds power, but here is the TLDR. The dimming works via PWM, which is the standard way of dimming LEDs. The voltage looks like the picture on top. From that we can get the PWM duty cycle and the maximum voltage during on. The switching frequency is also measured here. For this dimmer board, it is 15.5 kHz, which is quite fast and definitely done in a way that there is no visible flickering, even for cameras. There is another switching frequency for the CC driver. That leads to a ripple during the on phase, and that has a frequency of 322 kHz. Additionally, I measured the on current the LED gets during the pulse. I used the automatic detection included in the oscilloscope, and it matched what I would have eyeballed anyway. These are the most important data points I got with this method. Due to the CC driver, the voltages are very different between colors. This also means that the duty cycle is not used to limit the power. It is for every color between 46 and 62%, which is quite close together. On the right of the table, there is the current during the pulse and the corresponding power per color. In total, the power adds up to 6.46 watt supplied by the dimmer board. This is lower than the advertised 10 watt, 35% to be precise. And, I mean, one could say all these Chinese manufacturers do that. But say if I bought a 10-meter cable and I only got a 6.5-meter cable, I would be quite annoyed if that happened to me. And this is exactly what they do here. The manufacturer is more honest than the other ones that claim 30 watt, so props go out to Shehds, but you can do better. Just say the LED has 12 watt and it is driven at 7 watt. Completely fine. Problem solved. Everyone knows what they're getting into. All is fine. Finally, a quick word on the strobe behavior. I am only testing the strobe with the menu on the fixture itself, not with DMX. There we can set a strobe value between 1 and 99, and according to the number, the pause time between the pulses decreases. The light pulse stays rock solid at 30 milliseconds, and you can see the pause time in the table. Of course, the strobe is overlaid with the standard PWM signal. I did not notice strobe jitter when fading. They advertised strobing between 0 and 10 Hz, and that is not what I measured, with the maximum frequency being 16 Hz, which is definitely much welcomed. I did test the DMX control. It has a 4 and an 8 channel mode, which both work. The manual from the package provides the DMX description for what which channel does. Nothing special in that regard. The sound to light function is useless as always. There are the same 9 standard options, and it is not sensitive enough, and the microphone is buried deep inside the fixture. Why even include the sound to light mode if it is so completely broken? Thanks to the person from Reddit who gave me the idea, I tested if this fixture has a secret menu. It has one, and you get there by pressing the menu button for 3 seconds. In the secret menu, you can set the maximum brightness, the power reaches when setting the DMX value to 255. Effectively, this is an upper limit of sorts. Secret value number of 255 means that at the DMX value of 255, the duty cycle and of the according color is 100%. When it is not 255, the fixture takes the secret menu number, for sake of argument being a 16, and distributes it over the 255 DMX values you want to give to the power via DMX. This would mean that the LED is off for the DMX values of 0 to 15, on the lowest duty cycle for 16 to 31, and so on. From the factory, the values for the individual colors are shown on the table. The nice thing is that the driver, the CC driver, helps immensely offsetting the low resolution in this menu. The LED just won't jump that hard when first seeing voltage when the current is limited. So this menu gives you the option to do quite interesting things with the Pinspot and to increase the power. Later there will be a section about possible modifications and the evaluation based on that. And if anyone has an idea what NOD and DIP do, then please let me know. Let's proceed with the detailed look at the power supply. The writing on the side tells us it should have 1.5 amps at 12 volt, which should mean it has a power of 18 watt. I was, however, not able to do a good efficiency measurement due to the minuscule power of the power supply. But at 10 watt, on the DC side, it needs 15 watt of AC power, equaling an efficiency of 67%. That is not unheard of, but it is also not very good. The unit has a short circuit protection in the sense that it switches off when a short circuit occurs, and it has an overcurrent protection that kicks in at not even 15 watt of output power. There is no hot and cold side separation by a gap in the PCB, and the power supply is compatible with 90 to 240 volts AC from my testing with my beefy variable AC transformer. I live in Germany, which is a 240 volt 50 Hz country, and I gradually lowered the input voltage. At all colors full on, it was able to supply the LED and the brightness stayed the same, and so I would claim that it should be compatible. The input is not fused. The idle power is around 1 watt and the full-on power 8.5 watt. I'm no electrical engineer and thus I cannot evaluate whether or not this thing is safe, but I have not too much trust in this power supply. It is only barely sufficient for the power requirements of the fixture, but at least it switches off if it is overloaded. But it should be able to support the LED with the advertised power of 10 watt. The main problems of the Pinspot are in my opinion the following: the bad enclosure, that the spot is not zoomable, the loud fan, the lower power than advertised, the ugly beam and the bad light quality for white. We can't really do anything about the first problem. It is what it is. The same goes for the zooming problem. We would need to completely change the optical pathway, and this is just unrealistic. The sound problem is fixable. However, if you want an actually nice Noctua fan, it will cost more than the whole fixture, so this is not really feasible. I compared the included fan with a cheap 40mm silence fan and came to the conclusion that it does not really help much by itself. More importantly, the PWM temperature controller is what the system needs. This should reduce the noise significantly and will set you back around €2 for the PWM controller and a few bucks for the PWM fan. The power is lower than advertised, but you can increase the base power by just setting the secret menu number higher. However, you will only get so far with this power supply. I would increase the power moderately so that the fixture at least pulls 10 watt for full on, which the power supply should be capable of. The ununiform beam and the color quality is probably the only thing actually possible to solve, to some extent at least. The fringing is just how it is with this design of LED. But if you are okay with giving up the RGB, you could replace the whole LED with a single color warm white or cold white LED, or single color LED in whatever color you want. In this case, the light quality would be way better if the LED was better, and you would no longer have color fringing. But obviously, if you don't have RGB color mixing, this fixture will be a lot less versatile. Generally speaking, if the one LED fails, the fixture is dead. But that is to be expected for a Pinspot light with a singular LED. The fixture assembly is completely screw-based with no glue, but the bad quality case makes screw holes not aligned and screws in plastic won't take more than a few times of unscrewing. The inside of the fixture is highly space constrained, which makes replacing, for example, the power supply with another model very hard to impossible. And yeah, with that we get to the wrap-up and the price evaluation. The Pinspot works, which is always nice. It is a sharp spot with a uniform brightness, also good. It has a good dimming curve and a CC driving method. This is hugely important in my opinion. There was a good internal cable management and the LED power is as advertised. Last, it has an CE certification and an actual heatsink. The noise level is a problem, albeit not a big one. I personally don't really trust the power supply, or rather I would like to see one that has a bit more of power headroom. Speaking of power, it is not as advertised. And last and probably worst, the white is ugly and there is this awful color fringing due to the optical design. It just looks not good. All this you get for 12 to 20 euros. Normally, I do a comparison to other options in the market, both cheap and expensive, but this is in some way one of its kind. I was not able to find a reputable source of a comparable Pinspot that has DMX controllability, which is in my opinion a must-have. So the only other fixture for which a comparison would make sense is the UKing or another company, 60 watt RGBW Pinspot. I have this Pinspot as well, and while it is different and more expensive, it makes so incredibly more sense in my opinion. But that will have to wait until the next video when I actually review it. Personally speaking, I am torn. When I first tested it, I really hated the fixture due to its case and the bad light quality. But after realizing it is constant current driven and has a good dimmer curve, I can't really hate the Pinspot. It is so cheap that you can buy 5 to 6 pieces for under 100 euros, and throwing that many spots on a stage with fog, yeah, that will probably look pretty nice. Or to illuminate a disco ball. And you have the DMX controllability for less than a pizza. At least in the big cities, pizzas cost that much sometimes. But I would want to highlight specific things on stage, and for that I find it unsuitable. It is just cheap rubbish with a function. It is incredible how much they are able to do with sub 20 euros, sure, but the value proposition is still not good enough for me. I would rather pay 30 euros and get a fixture with some drawbacks instead of 12 euros for one that can't stop screaming, "I am a cheap compromise." And unfortunately, this fixture does exactly that. It is a cheap compromise. It is cheap, yeah. It is impressive, yeah. But it doesn't look good. And in the end, I would rather pay a little bit more to get way more. For the moment, the only thing left for me to do is to thank you for your attention, and may your path be illuminated by a bright but not burning Chinese LED power, and goodbye.